The next problem in the example exam has to do with DC steady state behavior. So DC steady state behavior says if nothing is changing in the circuit, then no matter how many capacitors and inductors you have, capacitors will look like opens and inductors will look like shorts. So let's take this particular case of a 2-volt source. We've got a 2-ohm resistor here. I'll call this I1 going through it. And at time equals 0, the switch moves from its upper position, from its lower position to its upper position. And the question, two-part question. The first question is to find all the variables. So find I sub 1 through the 2-ohm, find I sub C through the capacitor, find I sub L through this inductor, find V sub C across this capacitor, find V sub L across this inductor at both t equals -3 and t equals 0 minus. So if you're not prepared for looking for DC steady state, you might think clearly the circuit is changing because at t equals 0, it does change. The switch moves from the lower position to the upper position. But look at these times. In these times, t equals -3 and t equals 0 minus, in other words, just before the switch is thrown, nothing has changed in the circuit. It's been in that configuration forever. And if it's been in that configuration forever, it is DC steady state. And that means you can redraw the circuit as a DC steady state circuit. So in that case, the switch, if it moves up at t equals 0, for time less than 0, it's got to be down. So our circuit looks like this. Our capacitor is open. And here's our V sub C, V sub L, and we've got I1, IL, oh, and we need to have IC. Okay. And so this is what it looks like for time less than 0. So now we can solve for everything. By inspection, let's do the easy ones first. You might IC, there can't be any current that goes through this open. So therefore, IC has to be 0. We want to find I sub 1, we want to find I sub L, we want to find V sub C, and we want to find V sub L. So it might be tempting to say by the same reasoning that V sub C has to be 0 because it's open. But you know that's not true, because if I handed you a battery, that's also an open, there's no current flowing. And yet that battery, if it's a 9-volt battery, has 9 volts between the terminals. So you can certainly have a voltage even if there's no current. So we have to start redrawing some things. There is one easy thing we can see just by examination though, and that's V sub L. The voltage across a wire is always going to be 0 because there can't be any voltage dropped across this wire. So V sub L has to be 0. So that gives us a start. And now I think it's clear that V sub C, the voltage between this point and this point, is the same as between this point and this point, right? Because it's connected by a wire, there's no difference, which is the same as the voltage across there, it's connected by a wire, which is the same as the voltage across there. In other words, if we just take V sub C and rotate it sideways, we get V sub C. We just move this negative corner right around the wire, and we move this positive corner right around the wire until it's across the 3. If only we could do that across the 10-volt source, we know it's 10 volts, but we can't, because although we can move the negative side over, we can't move the positive side and jump over the 2. There can be a voltage drop by that too. But now we know we've got this voltage source here. And we've got a 2 resistors, one to 2 ohm and one to 3 ohm. And I'm just going to rewrite where our currents are. I1 is through the 2. IL is the same as through the 3. And VC is across the 3. And I think those are the only 3 things we've got left. So let's analyze it. This 10-volt source sees a total of 5 ohms. So you might say, how did we do that? We said these 2 resistors are in series. So we redrew it like this. And you might protest that, didn't we destroy our I1 and our IL by that? The answer is no, because although we did destroy all voltages and currents to the right of the thing, to whatever we simplified, we can take this I1 out, and it's the same as this. And we can see if whatever's current's going through the 3 is the same as the current that's going through the 2, which is the same as the current that's going through this wire. And so since we can take it out, we can redraw it over here. And so by inspection, this is equal to 10 volts over 5 equals 2 amps. So I1 is 2 amps and IL is 2 amps. Now, if we know that there's 2 amps flowing everything, we have lost our VC. When we combined 2 and 3, that VC, which is just across our 3, did totally get destroyed. But we can now, that we found out that this current is equal to 2 amps, we can go back and say, if there's 2 amps to this 2 ohm resistor, there must be 4 volts across it. If there's 2 amps to this 3 ohm resistor, by Ohm's law, VC has got to be equal to that 2 amps times the 3 ohms, which is 6 volts. And now we found all of the voltages and currents within this DC steady state circuit. There is a part B to the question, and the part B to the question says, find the total charge on the capacitor at time equals -2. Well, that made me realize we never really completed this first question, which is find that at t equals -3 and t equals 0 minus. And the answer is that it's the same circuit for time less than 0. It doesn't see any difference between time -3 and time 0 minus, or time equals -17 or time equals -10 centuries. It's all looks like this. The capacitors are all open and the inductors are all shorted because it's been this configuration forever. Okay, now, second part says, find the charge on the capacitor at time equals -2. So to find that, we're going to have to remember the formula for the charge on the capacitor, which is equal to the capacitance times the voltage on the capacitor. Again, that should kind of make sense that in your hydrodynamic analogy, that C is the floppiness, the size of this diaphragm. When it's really huge, it holds a lot of charge in there. When it's really small, it holds just a little charge. So it's linearly proportional to C. It's also linearly proportional to V. The bigger the voltage, the more it will distend and the more water it can hold inside the diaphragm. So this is the equation. And so what it's really saying is, what is the voltage at time equals -2 on the capacitor? We know the capacitor is a 1/2 farad. And for any time less than 0, the voltage on that capacitor, we said over here, is equal to 6 volts. So there's 3 coulombs of charge stored in that capacitance's electric field at time equals -2. Also at time equals 0 minus or at time equals -2 centuries, anytime before 0. There's one last part to this problem, and that is find the energy stored inside the inductor at time equals 0 plus. So that's tricky because at 0 plus, the switch is closed and now there's all sorts of currents and voltages changing in the circuit. Formula for the energy in the inductor is 1/2 L, the current through the inductor, squared. So if we want to find the current at 0 plus, it's going to be 1/2 times the inductance, which is 2, times the current through the inductor squared at 0 plus. Now, in general, currents and voltages can change between 0 minus and 0 plus. They can change instantaneously anywhere in the circuit, with the exception that there is something called voltage continuity for a capacitor. Same thing as saying the voltage across a capacitor cannot change instantaneously. And there's also current continuity for an inductor. And that's that the current through an inductor cannot change instantaneously. So in other words, although I don't know the current at times plus, it's got to be for an inductor, and only for an inductor, the same as the current at times 0 minus. And that's, we already figured out over here, it's going to be 2 amps squared. So that's 4 times 2 is 8, divided by 2 is 4 joules. Tricky problems, it really requires you to know a lot of things, that in DC steady state, nothing changes, and voltage continuity for a capacitor and current continuity for an inductor. Now, although I sub L at 0 plus is 2 amps and V sub C at 0 plus is 6 volts, and all these other values could have very well changed between I0 minus and I0 plus.